All right, welcome to AP Calculus, section 5.1 to 5.4. This is the test review part 2. We're going to be working these problems listed here. This, I believe, is going to be my last video for academic year 2023-2024. So those may be famous last words, but I think that's where I'm at. So it's kind of nice to be finished for the academic year. So we're on page 403, and number 27 through 32, you're just finding the inverse on all of these. So we're going to use the swap x and y and then solve for y technique. So for 27, we have y equals 1/2 x minus 3. We swap the x and y and have x equals 1/2 y minus 3. Add 3 to both sides. We have x plus 3 equals 1/2 y. And then multiply both sides by 2, and you'd have 2 times x plus 3 is equal to y. And that's our inverse function. For 28, y equals 5x minus 7. Swap the x and the y and have x equals 5y minus 7. Add 7 to both sides, and we'd have x plus 7 equals 5y. And divide both sides by 5. X plus 7 over 5 equals y. That is the inverse. All right, for 29, we have y equals the square root of x plus 1. Let's swap the x and the y. Square both sides to lift the radical. You have x squared is equal to y plus 1. And then subtract 1 from both sides. X squared minus 1 equals y. This is only the inverse when x is greater than 0. Okay, so we do have a domain restriction on this because you can't get a negative value, so if from the square root here. So if x, let's say, were -1, you wouldn't be able to get that from this because you can't take the square root of a negative. All right, number 30, we have y is equal to x cubed plus 2. Swap the x and the y, and then we're going to subtract 2 from both sides. So we have x minus 2 is equal to y cubed, and then take the cube root of both sides. I have the cube root of x minus 2 because it is equal to y. And that is your inverse for number 30. Number 31, we have y is equal to cube root of x plus 1. Swap the x and the y. Cube both sides. You'd have x cubed is equal to y plus 1. And then subtract 1 from both sides. X cubed minus 1 is equal to y. All right, 32. I hope you recognize that this is a parabola. That is going to fail the horizontal line test. Okay, so I'll go ahead and swap the x and the y. X is equal to y squared minus 5. Add 5 to both sides. And then take the square root of both sides. And we would have plus or minus the square root of x plus 5 equals y. That is not 1-to-1, at least over its entire domain. If we were to restrict the domain, then it would have an inverse. But you're not going to have to worry about figuring that out on the test. If there is a domain restriction, I will give that to you. All right, that does it for the first 6 problems. Now let's move on to number 41. So we're going to take these next several problems. We're taking the derivatives. So 41, we have f of x is equal to the natural log of e to the minus x squared. Now, it is so much easier if we use the properties of logs to rewrite this. So f of x, we can bring that exponent out front, minus x squared times the natural log of e. What's the natural log of e? That's 1. So f of x is just equal to minus x squared. F prime of x then is just negative 2x. You could get that without using properties of log, but it's much more of a pain in the caboose to do it that way. All right, 43. we have g of t is equal to t squared e to the t. All right, that's going to be a product rule. So g prime of t is the first, t squared, times the derivative of e to the t, which is e to the t, plus the second, e to the t, times 2t. All right, so just cleaning that up a little bit, that's t squared e to the t plus 2t e to the t. Now, I would be fine with this. I'm going to go ahead. The book factors out a t e to the t, I believe. And so you would be left with just t plus 2 when you do that. I don't see that this is a whole lot better than this, so I don't really know why the book does that, but I would accept either one. But it's good for me to show you how they get their simplified answer, because you may have teachers in your future that force you to do that. So 45, we have y is equal to the square root of e to the 2x plus e to the minus 2x. Now, let's rewrite this as y is equal to e to the 2x plus e to the minus 2x to the 1/2 power. And now we can use the chain rule, y prime, bring that 1/2 out front. You'd have e to the 2x plus e to the minus 2x to the negative 1/2 power, and then times the derivative of this inner function. So the derivative of e to the 2x is 2e to the 2x, so e to the 2x times 2. And then the derivative of e to the minus 2x is negative 2e to the 2x, right? So e to the negative 2x times negative 2. So that would be minus 2e to the minus 2x. All right, so let's clean that up. You'd have 2e to the 2x minus 2e to the minus 2x over, let's see, 2 times e to the 2x, or the square root because it's negative 1/2. So e to the 2x, I'm going to go ahead and see that 2 is out front, minus, let's see, plus e to the minus 2x. So those 2's would all cancel, wouldn't they? And you'd have e to the 2x minus e to the minus 2x over the square root of e to the 2x plus e to the minus 2x. So I would like you to see you cancel out all those 2's, but you don't have to rationalize or anything like that. All right, so pretty fancy problem there, but a good one to practice, because you could easily get one, of that level of difficulty on the test. All right, we're through number 45. Let's move to number 49. And we have g of x is equal to x squared over e to the x. Going to have to use the quotient rule here. So g prime of x, the bottom, e to the x, times the derivative of the top, 2x, minus the top, x squared, times the derivative of the bottom, e to the x, all over e to the x squared. So that would be e to the 2x. All right, so let's see what we could, if there's anything that we could cancel here. Let's see, we could factor out an x e to the x on top. and you'd be left with 2 minus x. So distribute that if you disagree with me, but that would work. And then over e to the 2x, and then we could cancel this e to the x on top and then one of these, and you'd have x times 2 minus x over e to the x. So that's how the book simplifies. I would count this problem correct on a test if you got here, but I do think it's very useful to see how the book gets to there. All right, number 50, we have f of theta is equal to 1/2 e to the sine 2 theta. So f prime of theta would be 1/2 times e to the blop, sine 2 theta, times the derivative of sine 2 theta, which is 2 cosine 2 theta. So it's cosine 2 theta times the derivative of the angle, which is 2. The 2 and the 1/2 cancels. So we end up with, and let's see, I think it's okay to write it like this, e to the sine 2 theta times cosine 2 theta. And if you want to bring the cosine 2 theta out front, that probably would look a little better so you wouldn't have that gap there. Okay, that does it for the derivatives. So now let's go to the antiderivatives. Okay, 5 more to go for this academic year. So number 65, we are integrating x e to the minus 3x squared dx. Now remember, if you're integrating exponential functions, almost always involves u substitution. So if we let u, and a lot of times you end up with e to the u. A good first start is to use the exponent of the e as u and see what happens. So if we let u be minus 3x squared, then du is going to be minus 6x dx. We want it to just be x dx, right? So minus 1/6 du is equal to x dx. So I can rewrite that as minus 1/6 out front, and then I would have e to the u du. So that's minus 1/6 e to the u plus c, or minus 1/6 e to the minus 3x squared plus c. Okay, how could you check that? So you would just take the derivative of it. I do think that you should do that on your test. I can look at it with my eyeballs and tell that that is going to work. All right, 66. So this one's not in the back of your book, so you can check to see if you got it right. And this one is a little more difficult, maybe a little more difficult to see. But if we let u be 1 over x, then du is minus 1 over x squared dx. Now, you could do that with making that x to the minus 1, but this is what it is if you turn it back into fractions and positive exponents. Well, I need it to be 1 over x dx, or dx over x squared, right? 1 over x squared dx, excuse me. I'm almost there. Minus du is equal to 1 over x squared dx. And that's sitting in the problem. So we could rewrite this as minus e to the u du. And that's where we end up a lot of times. That's just going to be minus e to the u plus c. So minus e to the 1 over x plus c. All right, and you can take the derivative of that It's going to be minus e to the 1 over x times negative 1 over x squared. And then two negatives will cancel, and you'll be right back here. All right, great. 3 more to go. And I'll talk about the test just a little bit. Okay, 67. Now 67, this is the type of problem that so many students have trouble with. And boy, I wish they didn't. It kind of drives me crazy because it's such an easy problem. When you just have one term in the denominator, you don't want to try to use a u substitution here. It won't work. You divide e to the x into each of these terms. So we're going to simplify it algebraically and rewrite it e to the 4x over e to the x. You subtract exponents and you just have e to the 3x. 2x over x just leaves e to the x. And 1 over e to the x would be e to the minus x. So I just rewrote that whole thing by dividing e to the x into each one. Now I can integrate this, and I'm not going to use a u substitution on this. You can if you need to, but I can kind of do this with my eyeballs. The antiderivative of e to the x would be 1/3 e to the 3x. If you're not sure about that, take the derivative. It'd be e to the 3x times 3, and so I would need a 1/3 out front to get rid of, to make this back into a 1. And then the derivative of e to the x is e to the x. And for this third term, it would be minus e to the minus x, because the derivative is e to the minus x times negative 1, and that would make that into a plus, because it'd be negative times a negative there, plus c. So nothing wrong with doing the derivative with your eyeballs on a simple one like this. Okay, let's see if 69 will fit in there. That's e to the x over e to the x minus 1. So let's let u be e to the x minus 1. Because remember, we can handle u on bottom, but not du on bottom. So du, so we always want to, if we have a situation like this where you think, it could be either one, pick the u to be the one on bottom. So du is just e to the x dx. That's what we have on top. So we can rewrite this as just du over u. And you know that's the natural log of the absolute value of u plus c. So that's the natural log of the absolute value of e to the x minus 1 plus c. And I can check that by taking the derivative with my eyeballs. It'd be 1 over e to the x minus 1 times e to the x, which is just this. Well, I'm pretty excited to get to my last video problem of this academic year. And again, this could be famous last words and I end up having to make more videos, but I think it is. So let's do number 70. So number 70, we have x squared e to the x cubed plus 1 dx. So what makes sense for you is x cubed plus 1. A lot of times it is the exponent of the e value. You take the derivative of that, it's 3x squared dx, and that's, you need it to be x squared dx. So you can multiply both sides by 1/3. And we would have 1/3 out front. And it'd be e to the u du. That's going to be 1/3 e to the u plus c, which is 1/3 e to the x cubed plus 1 plus c. Now let's make sure that's right by taking the derivative of that. That would be e to the x cubed plus 1 times 3x squared times 1/3. The 1/3 and the 3 would cancel, and you'd have that x squared right there. And so that will do the trick. So for the just a little bit of a test chat here. This is a really good review. don't forget, so if we look at your test review little spreadsheet that you have here, I didn't have any extra problems for 5.3b. So you just need to study that worksheet with the formula for the inverse derivative. Okay, study that worksheet. You will definitely get at least one problem on that. What I would say is study 5.3b worksheet. We didn't have any of these on the review, so study the trig integration, formulas. All right, that's in section 5.1. So we didn't have any of those on the review, but you'll want to maybe rework some of that homework. I would rework any of the homework that gave you trouble. So if you had trouble with any the first time, in terms of, you know, a review, this review assignment did a pretty good job of derivatives and antiderivatives of natural logs and e's and a little bit of inverse stuff. But you're gonna have to look over those. And then there's no multiple choice or true false on this test, so you really just have to worry about working problems. So there you go. That's about it. And I hope this class prepares you well for Calculus 1 in college. Good luck in your future. And keep me updated on how you're doing. So friend me on Facebook, whatever, but I'd love to be able to wish you a happy birthday, and see how you're doing, how your studies are going, and what things happen in your life. So God bless, and I will talk to you hopefully soon.